Hey guys, welcome back to another Further Stats 2 revision video. In this video today, we're going to take a look at the continuous uniform distribution, sometimes known as the rectangular distribution. This is partway through chapter 3. Not the trickiest topic, but can cause some issues, so let's jump straight into it and see what we've got. So in this first question here, we're taking a look at an old exam question from S2. And we've got a continuous random variable x, which is uniformly distributed over the interval -1 to 3. Okay, so this question, it's nice in the way how it lays everything out. So the first part, we're just asked to find the expectation of x. So let's just do this. So question 3, part A. So to find the expectation of x, remember that's just the mean of the distribution. And for this, we can just use the formula book. So in the formula book, you'll see the expectation of x is defined as a plus b divided by 2. And remember, a and b are represented by the interval here. So in our question, our a is -1 and our b is 3. Okay, so that's our interval there. So now, all we need to do is just start calculating this using our variables. So a plus b, so -1 plus 3, divided by 2. So 3 minus 1 is 2. So we get 2 over 2, which is just simply 1. Okay, so 1 mark there, that's the expectation of x. The variance of x, again, just given in the formula book, so nothing too tricky. How would we do this? Well, we just use the formula, so that's b minus a all squared, and we divide this by 12. In the formula book, I think it does b minus a squared times 1 over 12. It's just the same thing, I'm just dividing it by 12 instead. So, b minus a, so that's 3, minus a, where a is -1. So that's the same as doing 3 minus -1, so that's the same as doing 3 plus 1. We square this, and then we divide it by 12. So this is 4 squared over 12. 4 squared we know is 16, so I get 16 over 12, which we can simplify now to 4 over 3. Okay, so that's the variance of x. The expectation of x squared is a little bit trickier, but it's not too bad. So the expectation of x squared, how do we calculate this? To calculate the expectation of x squared, all we're going to do here is use the fact that the variance of x plus the expectation of x squared is equal to the expectation of x squared. Okay, we can use that fact to calculate this. So the variance of x we've already worked out, that was 4 over 3. That's 4 over 3. The expectation of x squared, oh sorry, the squared should be on the outside. There we go. So the expectation of x squared, or the expectation of x all squared I should say, I'm having a bit of a nightmare, plus 1 squared. So 4 over 3 plus 1 squared, so that's just the same as plus 1. So this would be 3 over 3, giving us 7 over 3. Okay, so 7 over 3 there for the expectation of x squared. So hopefully not too bad there. So that's the expectation of x squared. Part D, we want to find the probability that x is less than 1.4. Probability that x is less than 1.4. So this is where I think a sketch comes in handy for a question like this. So let's just do a sketch of our distribution. This would be f of x for our PDF. This would be x. So the interval is -1, so let's just say that's there, to 3, we just say that's there. And we have this height here, which we don't know yet. Let's just call that, I won't choose A, let's just call it F. Okay, F for our height. And our distribution is, like we said before, it's a rectangular distribution, that should go to 3. With this height F that we're going to work out. Now if we think about it, this distribution, the area of the rectangle should be 1. So what would this height need to be in this case? So what do we times the distance here by, which is 4, minus 1 to 0 is 1 unit in length, plus another 3 units there. So the length here along the bottom is 4 at the base. So what do we times 4 by to get 1? Well, in that case, that would clearly just be a quarter. So this here, f, is a quarter. So that's that point there. Okay? So that's a quarter. So now what we want to consider is, where is this less than 1.4? So let's just say this is 1.4. What we want is everything that's less than that, which is everything to the left of it. So we want this area here. We don't want anything to the right of it, that's greater than. Everything to the left we do want. So in that case, we just need to find the area of this new rectangle. So what is this area? Well, that area would simply be 2.4, the base, 2.4, and we times it by the height by a quarter. So this is the same as doing 2.4 divided by 4, and we can just start simplifying here, or you can just use your calculator. So after 1.2 over 2, and then obviously half of 1.2 is 0.6. Okay, so we get 0.6 there. A bit of common sense here. If you get some crazy answer, so a crazy answer here would be an answer larger than 1. Remember, this is a probability. So if you get something larger than 1, something's gone wrong. If you're getting negatives, something's gone wrong again. So just use a bit of common sense. It's a probability, so the standard rules and laws for probability should still apply here. So let's just clear all this and have a go at part E then. So I just draw the distribution again, just so we've got it. The reason I'm drawing the distribution again is for part E, we've now got a total of 40 observations. And we want to find the problem that at least 10 of these observations are negative. So let's just consider this the case, or the scenario, of one of these being negative. So if it's negative, that means everything in this area here, from minus 1 to 0, that's negative. Okay, so we want the area of this rectangle here. Well, that's just simply given by 1, because this is 1 unit in length, times by the height, which is a quarter. So that just gives us a quarter there. Okay, so what I'm going to do here is I'm going to define this as a new variable, and then we're going to consider this as binomial distribution, because we've now got 40 observations. So what I'm going to say is that Z is a binomial distribution. We've got 40 observations, so n is 40, and my probability is just what we've worked out here, a quarter. That's what one observation gives us for the probability. So that's a quarter there. So all we need to do now is consider that the probability of at least 10 of these being negative. So what we're actually looking for here is probably that my new variable, Z, is greater than or larger to 10. Okay. Or greater than or equal. I can't speak today. So Z is greater than or equal to 10. And then this is just a standard binomial probability question here. So hopefully it shouldn't cause too many issues. So what I need here is a probability of 1 minus less than or equal to 9 like so. And at this point here, I just plug this into your calculator, which if you do that correctly, you should get 0.561. Okay, so 0.561 there. So quite a long question actually, but hopefully not too bad. So let's take a look at the next question, a bit shorter. So we've got another continuous random variable L, which represents the error in meters of a machine cutting some lengths. So the interval that we're using is 0 to 0.5. Okay, so that's a 0 there. The first part is just a standard probability. Find the probability that L is less than 0.4. So again, if you're asked to find a probability, do a sketch. It will help you massively. So if I do my sketch here, so it's between 0, which is here, let's just say that's 0.5. Again, it only has to be a sketch. And let's say this is my height. This time let's call it H. Okay, so this is our rectangular distribution now. Well, I want the probability of L being less than 0.4, so if that's 0.4 there, we need everything to the left of it. Okay, so we want this area here for this rectangle. But first we need to work out what the height is. So what would the height be? Well, what do you times a half by to get 1? Remember, this whole area for the rectangle has to be equal to 1. So in that case, h must be equal to 2. 2 times a half is equal to 1. So h is equal to 2. So now we've got our sketch of our PDF. Now all we need to do is work out the area of this rectangle. So again, base, so that's a length of 0.4, times by the height, which is 2. So 0.4 times 2 is 0.8, or we could obviously write that as 4/5 if you prefer. Okay, so that's probably that L is less than 0.4. Part B, we want to write down the expectation of L. So remember, the expectation of L is nice and easy, just given in the form of the book. So that's going to be A plus B divided by 2. And remember, this is your A and this is your B. So 0 plus a half, that would be 0.5, and then we divide it by 2, which will give us 0.25, or a quarter there. And then finally for part C, again another standard one, just calculating the variance now. So the variance of L, well, again, just use your form of the books, that's B minus A all squared, and then we divide it by 12. Well, B is 0.5 minus 0, so that would be 0.5 squared divided by 12. And then just put this into your calculator. So this would be obviously 0.25 divided by 12. And again, you can just do this on your calculator if you want. So this will give you either 1 over 48 or 0.0208. Okay, and I see that one was quite a quick one. But again, pretty standard, hopefully nothing too tricky for that one. The next one then, we've got a couple of different parts here that we haven't seen yet. So the first two parts, we have to write in the full PDF, and then we actually want to sketch the PDF. So we've already kind of done a couple of PDFs that we've drawn, but we've not stated a full PDF yet. So let's do that. So the first thing to consider is the interval. So -2 and 7. So for this question, I've actually considered doing them both together, part A and B. They do go quite nicely together. So what I'm going to do first is I'm going to do my sketch. So my sketch, again, don't have to be amazing, it is just a sketch. But at least use a ruler in your exam, don't do what I'm doing here. So this is f of x, and this would be x here. Okay, the interval is -2 to 7, so that's -2 there. Let's say that's 7. And obviously we're going to have this height here, so I'll just put that in there. Okay, so the only thing remains here is, what is this height? How do we calculate that height? Well, again, just like we've been doing, we need to consider what do I times this by now, the base here, what do I times that by to get an area of 1 here. In this case, this would be 9, -2 to 0 is 2, and 0 to 7 is 7, so 2 plus 7 is 9. So what do I times 9 by to get 1? Well, that would clearly just be 1 over 9. The other way you can do this, which I believe the textbook shows, is you could do this as 1 over b minus a. That's the other way they do it. Okay, so 1 over 7 minus -2 gives you 1 over 9. Okay, I don't like this way though, because intuitively it's just memorizing a formula, whereas if you actually understand why the distribution is equal to 1, because the probability distribution, in that case, you know, we're just doing the base times the height is equal to 1. In that case, it's just a simple GCSE maths question. So that's the other way you can do it if you're unsure, but I think that's the more intuitive way here. So that's our sketch of the PDF. So that's 1 over 9. Okay, that's terrible. 1 over 9. And then we want to write down the full PDF. So the PDF is just simply given as f of x. Well, in this case, if you think about this, we've got 9 possible values, and each one is uniform, so each one must take the same probability, so it's 1 over 9. So we've got 1 over 9 when x is between -2 to 7. Like so. And in any other case, it would just be 0, so 0 otherwise. Okay, so hopefully that's not too bad. Part C, we saw something similar before. So let's just clear all this first. So part C, we need the expectation of x squared. So to do this, we need the expectation of x, we need the variance of x, and then we're just going to do the variance of x plus the expectation of x squared. So, expectation of x, again just using our formula book here, this is a plus b divided by 2. So 7 plus minus 2, in other words 7 minus 2, so that's 5 over 2, which gives us 2.5. Okay. Hopefully not too bad. The variance of x, again just use your formula book. B minus a all squared divided by 12. So this would obviously be 7 plus 2, because 7 minus 2. And then we divide that by 12. We just need to square this. So this would be 9 squared, so that's 81 over 12. Which, if you put that into your calculator, gives you 6.75. Okay, so now the expectation of x squared, remember, is just simply given as variance of x plus expectation of, oops, I keep doing that mistake, expectation of x all squared. There we go. So now just plug everything in here. Variance of x is 6.75. Expectation of x, and then square it, so that's 2.5 squared. And I've just plugged this into my calculator, and this gives us 13 there. Okay, so nice and easy, hopefully. Part D is just a probability one. Now this one's slightly different because the probability is between two values. But again, a sketch here makes this question nice and easy. So let's just do a quick sketch. So if you've done part B, you will already have your sketch. But if I quickly just do it again, that's 1 over 9, and then minus 2 to 7. Okay. So here now, I want the probability that x is between minus 0.2 and 0.6. So let's just say this is minus 0.2 there, and then let's just say this is 0.6. So what have we got? Well, we've got a new rectangle, and I want this area here. Okay, we want to know what that area is equal to. So again, just do base times height. So the base is a length of 0.8. It has a height of 1 over 9. So we times this by 1 over 9. So I get 0.8 over 9. You could times top and bottom by 10 here if you wanted to make this a bit easier to calculate. So that would be 8 over 90, which you could also write as 4 over 45. And if you're writing that as a decimal, it'd be approximately 0.0889. Okay, so that's a nice way of doing that one. So that's the full question done. So let's take a look at the final question here. This can be quite a standard question. Can be a little bit tricky depending on the numbers, but in this case I don't think this is too bad. So the context of the question actually doesn't matter for part A. Someone's catching a train and it's modelled as a uniform distribution. What we're told is that the interval is alpha and beta, and we're also told the expectation of x is 4, and then the variance of x is 12. Okay, so that's what we're told. And we're just asked to find the value of alpha and the value of beta. So for this, what we need to consider here is the formulas for the mean, the expectation of x, and the variance of x. And then see if we can try and basically put everything together to get a value of alpha and a value of beta. So the first thing I'd do here is consider the expectation of x. So that's alpha plus beta divided by 2. Okay, just using a plus b divided by 2 is equal to the mean. So this is equal to 4. Okay. The variance, so that's going to be beta minus alpha all squared and then divided by 12. And this, again, this is equal to the variance of x, which is equal to 12. So what I'm going to do first, if I just call this equation 1, and I call this equation 2, I'm just going to do a bit of manipulation for both equation 1 and equation 2. So equation 1, if I times both sides by 2, I get alpha plus beta is equal to 8. Okay, so just timing both sides by 2. I'll do the same here, but obviously times by 12. So I'm going to get beta minus alpha squared is equal to 144. So at this stage here now, we just need to kind of consider a way in how we can get this into one variable only. So in other words, substitution would probably be easiest here. So it doesn't matter how I rearrange here. So I can either rearrange equation, let's call this equation 3 here. This one's now equation 4. So if I rearrange equation 3 to either alpha or beta, it doesn't matter. It's completely up to you. All we're going to do is sub either one into equation 4. So I'm going to rearrange this to be alpha equals 8 minus beta. Okay, but like I said, doesn't matter, completely up to you. And what I'm going to now do is sub this into equation 4. So what do I get? Well, I get beta minus alpha, so minus this. So that would be minus 8, and then minus beta, that would be plus beta there. We square that, and this is equal to 144. Now at this stage, we just start simplifying. So this is 2 beta minus 8 all squared is equal to 144. And now I just want to start solving this. So two ways you can do it. You can expand that as 2 brackets and start trying to solve that way. The easier way would just be to square root both sides here. So if we do it all the way at the top, so if we square root both sides, I'd get 2 beta minus 8 is equal to plus or minus the square root of 144, which we know is just 12. Okay, so that's plus or minus 12. At this stage here now, again, just keep rearranging this until we've got it in terms of beta. So add 8 to both sides. And then finally, we're going to divide through by 2. So beta is equal to 8 plus or minus 12 divided by 2. Now at this stage here, we just have to be careful. Obviously, we can't have 2 values for beta here. This is just a continuous uniform distribution, so beta is just one of these values. But the question here now is, how do we choose which of these values it is? In this case, what we need to consider is the fact that in a uniform distribution, so let's just say alpha and beta, like we've been given, beta must be larger than alpha. Okay, when we write this uniform distribution, the second parameter is always larger than the first. So beta is larger than alpha. Okay, so let's just say I pick 8 minus 12. So let's just say we take the negative here. So 8 minus 12 divided by 2. So what I'll do is try all this out. So in that case, I'd get minus 2 here. Okay, we take the negative. So if beta is minus 2, we'd substitute this back into here, into equation 3 to get alpha. Or this rearranged form here. So then alpha would be 8 minus beta. So 8 minus 2, that's the same as 8 plus 2. Alpha would be 10. Okay, which is clearly an issue. In that case, this inequality here does not hold. So what we need to do is just take the positive. So in that case, beta is 8 plus 12 divided by 2. So 8 plus 12 is 20 over 2 gives us 10. So because that's equal to 10, all we need to do is plug this back into here. So therefore, just do it in a different colour. Let's do it in a light green. So in this case, beta is equal to 10, and alpha is 8 minus beta, so 8 minus 10, giving us minus 2. Okay, so our interval, if we want to write it over here, is minus 2 to 10. Okay, and there we have it. So 5 marks there, hopefully not too bad. So that brings us to the end of this video. I hope this has helped. If there is any issues, anything that's unclear, like always, just leave a comment down below. Cheers.